So now, in the interest of time, let me start with a talk. And in this talk, I'd like to give you how I think about how I think about the decisions of a maintainer. Is this supposed to be in a different session? I have no idea, honestly. Does anyone of the organization team knows if we should be switching to another session? Chris says to stay here. There is another. Can somebody comment in the other session that it's happening here? This is unfortunately confusing. I'm sorry. Yeah. So can somebody comment there that basically it's happening here? We're learning this system. This is the first time we do a pandemic conference. All right, and so I'll get going with my presentation. So really, my presentation, the goal here is to tell you how I think big picture and strategy in terms of making the maintainer's choice. And the reason why I wanted to have this presentation is because really our goal here is to grow more maintainers. I'm not the only maintainer of Nilearn, we have plenty, but we want to have more. We want to have people who basically think in the long run, who think in the big picture in the long run. And so the challenge is really, how do we live long and go far? How do we make sure that we're still here with an amazing project that is still as vibrant and as dynamic in 10 years? And so I've tried to come up with a bunch of different recommendations organized with nine recommendations, and I'll just talk about how I think each one of those aspects. The first thing is the notion of project vision. When you're doing a software project, it's crucial to have a clear vision of what you want to achieve and the scope. It's been mentioned earlier in the previous presentations, and this vision is going to guide any kind of marketing you do. You should be able to explain clearly what the project is about, because you don't want to oversell your project. Overselling your project is bad in the long run because you'll have disappointed users. And you want to guide your project choices. So you set a goal and you try to solve it. It must be focused. It must be easy to explain. It's important to know how you're positioning yourself with regard to the competition, because sometimes not creating a project is best. It's the idea that you should choose where to innovate and stick to it. Now, once you have this, our opinion in Nilearn is that you should build it with the community. And the point being that community-driven projects are much better than plain open source project. A plain open source project is a project where the code is open, but the project doesn't really take contributions and isn't really steered by a community. So we want a community because the community will go further. The question is, how do we achieve sustainability in the long run? And with a community-driven project, sustainability doesn't depend on a handful of individuals. Suppose I stop doing neuroimaging. I go in investment banking, for instance, to make a lot of money. And suppose Bertrand also goes in investment banking. Nilearn shouldn't stop. And for Nilearn not to stop, it means that we need to have as many people who are involved, but also feel in charge, not just contributors, maintainers. Now, this doesn't only give us sustainability. It does, hopefully currently, and it will in the long run give us better software. Because the people who come on board are users that want to solve a problem. We say scratch a niche. And so they want to solve a problem, so they're giving a focus, they're giving an orientation to the software that is driven by users for users. Another aspect is it avoids monoculture. We need to have contributors that come from all kind of different labs with all kind of different practices, and it's already the case. But we want to increase it even more. Bertrand and I tend to share too many things. We want to have more contributors and maintainers who disagree with us. A community, of course, doesn't happen by itself. It needs love. And for this, you need to invest in people. There's this great book that's called Peopleware that's about managing coders. And this means making sure that the communication of the project goes well. So whether it's online or with actual in-person events, such as sprints. No, currently the sprint will be online because of COVID. It also means that you need to make sure that your volunteers, the contributors, achieve their goals. And their goals are to learn. People contribute to learn, and they stay to learn, but also to achieve things, basically to help themselves solve their own problem, but also solve a wider community. So we need to make sure that everybody is productive. And this is one reason why we invest on core aspects of the project, such as continuous integration, or making sure that the project always works on the latest versions of our dependencies. And in the long run, of course, what we need if we want a real community-driven project is to relinquish governance. Basically, an open source project is successful when it does something that its founders hadn't thought about. And in this sense, I think Nilearn is already successful because we didn't do surface analysis. And now Nilearn is doing more and more surface analysis. But we want more of this. So the challenge is that a tiny fraction of users are going to become contributors, and an even smaller fraction are going to become maintainers. So this poses a real challenge for niche projects. It's very difficult to find the trade-off between the right project vision. So basically it needs to be broad enough to have enough contributors, but narrow enough to solve a well-defined project. Complexity is going to be a huge challenge to any project that grows. First of all, if our goal is to have a community, we want to be inclusive. And being inclusive means that we need to keep it simple. Every required skill that we add to the project, so for instance, C++, convex optimization, parallel computing, brain anatomy, will make it harder to contribute. A project's required skill set should lie at the intersection of the skills of sufficient people. And this is important to keep in mind because it means that we are going to give up on certain things because they require new skills. The goal is to not rely on a few super individuals, because then these super individuals become single points of failure. Finally, understanding is harder than building. There's this famous quote by Brian Kernighan. Brian Kernighan is super famous developer. He is one of the person who built Unix, the Unix operating system. And he once said that debugging is twice as hard as writing the code in the first place. Therefore, if you write the code as cleverly as possible, you are by definition not smart enough to debug it. So this is crucial to keep in mind. If you try to do something too complex, you will drown under it. Your everyday roadblock is the cognitive load. And as an example, try reading your own work. For instance, your own old code. You will find that your past self does not answer to emails, and that is quite annoying, I must say. The problem with complexity is that it has a superlinear cost. Features are costly. Empirical work has shown that if we increase by 20% the problem complexity, this will lead to an 100% increase in cost. So a small amount of increase in features will lead to a much larger amount of increase in complexity to solve those features. So it's extremely important to keep in mind the 80-20 rule. 80% of the use cases can be solved with 20% of the lines. So for this, we are going to have to say no to certain features, as it was mentioned earlier. This means that we're avoiding what we call feature creep. Feature creep will be adding features without good control. This goes back to the importance of having a well-controlled project vision and design. I'm not sure what happened here. Sorry, Crowdcast jumped, and I need to. There we go, we're back. Okay, so features are costly, but abstract code is also costly. We can do object-oriented programming, we can use design patterns, we can use multiple inheritance, we can rely on pure functional programming. If you want to be a super programmer, you probably need to study these things. It's useful to know them. It's useful to know not to use them. For many reasons. One, I suspect a significant fraction of the audience does not understand what it means. And it's fine, because they're not necessary, not always, very seldom. You should only use the sophisticated tool when you need it. You should always use the simplest possible answer for a given problem. So we need to know how to be sophisticated and to know not to be sophisticated. Let's talk about technical debt. Today's asset may be tomorrow's liability. For instance, the phone booth. For a company that has implemented hundreds of thousands of phone booths, it now needs to maintain them. They're no longer a good source of revenue. So we need to choose extremely widely what to include in a project. Is a given feature a pet project of someone or a killer feature? In science, this is challenging because investigators tend to have a bias towards their own publications. You should read my publications and cite them. They're awesome. However, from a software point of view, how do we know whether something is useful, revolutionary, or oversold? It's a very tough call to make because we can stick with the most well-known features, but that's not innovation. Innovation is finding the right features that we're going to include and that are going to empower people. And this is the difficult question. So I find that the right way to address this question is to prototype those features outside of the main project. Build a small sub-project and try to use it. And if that sub-project ends up being incredibly useful for you, then it needs to be included in the main project. That requires a lot of experimenting, not only on one use cases. It also requires you to refer to the project vision. Your project vision, once again, is going to be what is going to be the guideline in terms of making your choices. We need to limit drag. Basically, as we put on weight, it becomes harder and harder to maneuver the project. For instance, compiled code. Compiled code could make things faster in Nilearn, but it will extremely severely increase the burden. Another important aspect is installation. Experience shows that installation is where you lose most users. People try it, can't get it to work. Nah, I'm going to go back to my MATLAB code. So we need to navigate right the trade-offs. And one example of trade-offs is dependencies. Dependencies are crucial because they help us not reinvent the wheel. We didn't build a plotting library inside Nilearn. We reused one. We didn't build a machine learning library inside Nilearn. We reused one. However, each dependency is a liability. So we really need to gauge well whether a feature is crucial and absolutely need a new dependency and will suddenly transform our library to become the best thing since sliced bread, or whether we can drop that feature. And in general, we put a much larger barrier to anything that adds dependency. The reason dependencies are so challenging is that each dependency is a liability because the library can change in any kind of way, and you need to adapt to this change of library. You not only need to adapt to this change of library, but you need to adapt to the combinatorial of all your dependencies and their dependencies and their dependencies. So that combinatorial increases extremely fast. And you're going to have some corner cases where things go wrong because of the specific combinatorial of packages that a user has installed. Design, in particular product design. This is a hammer. It's also many other things, this is not an incredibly useful product. This brick of milk, on the other hand, is an incredible invention because it solves a day-to-day problem extremely well with very little technology. So the challenge is to use our technical sophistication to find the simplest possible answer to the original problem. Another example, in ergonomics, we have here two tabs, an old-style tab where I need to turn separately the hot water and the cold water, a new-style tab where the control of temperature and flow rates have been merged. This is a good example of an interesting industrial design innovation where the designer who came up with this innovation rethought the user's need and built a new tool that solves the user's needs better. Now, this is extremely hard, by the way. This is not easy. But each time we can do this when we do software, we are providing value to the user. So Nilearn is a Python library, and we are thinking a lot about the API of this library because this is basically our way of doing design. Here are a few guidelines. First, consistency is absolutely crucial. We want orders of arguments to be as close as possible. We want names of argument to be basically the same. So in Nilearn, there's a rule that if a name is made of two words, then there's an underscore between those two words. And it's a systematic rule, and there is no going around it because it reduces the cognitive overload. Functions are easier to understand than classes. Objects have hidden states. They have no universal input, output. We can do most of the things in functions. We're not dogmatic either. When we need a class, we use a class. A library, any kind of library, should hinge on a very small number of concepts because picking up the library requires learning all those concepts. So, which data structures are we going to use? What kind of objects are we going to have? Each time, this is a burden for the user to learn. So we need to reduce this as much as possible. Likewise, common data containers make the ecosystem stronger. So NumPy arrays, pandas data frame, nifty containers, this is absolutely crucial, and this is bigger than a single library. Each function should have only one purpose. We do not want change of behavior depending on the input type. As a consequence, a function should be easy to explain. We should be coding for interface, so basically not coding for a specific data structure, but rather for a specific content of the data structure. However, we need to be careful about objects that look similar but are not. In Python, we have the NumPy matrix and the NumPy array. That's the reason why the NumPy matrix is frowned upon by the community. If you're going to design objects, you should be aware of properties. Properties, for those who don't know, are a way in Python to expose an attribute that is computed dynamically by a method. The problem about this, so they allow you to basically adapt your object to give it any kind of surface, any kind of interface that you want. The problem with this is that they're obfuscating the data model of the object. So we try to avoid properties. Likewise, shallow objects and shallow APIs are better than deep objects and deep APIs. The reason is that a user, an advanced user or a beginner, understands an object by its surface, by basically what methods and attribute the object exposes. And if we try to do many composition, we get cognitive overload again. Error messages matter hugely, and warnings matter hugely. It's very important to explain the problem as well as possible in an error message, and I'm sure we can do many progresses in Nilearn. And if there's a value that triggers this error message, we should print it because it makes it much easier for the user who gets this error message to debug the problem. And finally, we want to be Pythonic. What we mean by this is that we want to have a syntax that looks like Python. We don't want to do syntax hacks. There are all kinds of ways of doing hacks in Python. We should avoid those hacks. We want to build our projects by iterations. So short cycles and limited ambition. We're not there to build a super complex object like a car from scratch. We're there to iterate, building the project more and more complex. And as we learn, we become more expert, we understand our problem space better, and we're able to do a better iteration. The value is that it allows us to keep coming back to our users. The way we do this, ideally, is by releasing early, releasing often. There's a trade-off to find here. In Nilearn, we try to release every 6 months. It's a bit long, but given the size of our maintaining team, there's the overhead of releasing. We have limited resources, but limited resources are good. We need success in the short term, not in the long term. It's the idea of the startup culture. We need to fail fast. So we need to identify quickly non-viable projects. We do not want to embark in very big endeavors that require many person years to solve, because we're going to spend those many person years and we're not going to be able to confront these to users. And after those many person years, we will know whether we're successful or not. It's the simplest solution that works at its best. That is absolutely crucial. The simplest solution should be doable in a reasonable amount of time to be able to present it to the user. Quality should be an absolute priority. Why? Because it will give us users, and on the other hand, bugs will give us a bad reputation. People would rather use a software without bugs, surprisingly. It will also give us developers. The reason it will give us developers is that people are happy to contribute to a project where they learn and they improve. And on top of this, it will make our developers happy, because people want to be proud of their work, and you'd rather work in a library which is well known as being a reliable library than a library where there is a terrible reputation. So we should do less and do better. Now, this goes against the grants incentive system. Tough luck. We're here to build a good product, and we'll do what we can with the grants. We need quality absolutely everywhere. We need great documentation, as Bertrand mentioned. Simplify things, but don't dumb them down. Focus on what the user is trying to solve. We need great APIs, as I said earlier. And for this, we're going to rely on example-based development. If our API is hard to explain, we're going to try to rethink the concepts, which means that we try to explain the API to each other. When somebody proposes a feature, I look at the examples to figure out what this feature does. If I don't understand the examples, I'm going to tell that we need to rethink the feature. As I mentioned earlier, we need to limit the different number of concepts and objects and to focus on consistency. We'll also have to focus on good numerics. So we'll write tests to check this. Our goal here is to enable reuse and just not being reproducible. We want people to be able to use this code on many different data sets and on many different problems. And now this is challenging because we need to find concepts and primitives that are reusable over many different applications. So to achieve quality, it's useful to have well-controlled process. Everything we do is based on code reviews. So every single code that is contributed to Nilearn is reviewed. There's a process online, and Elizabeth will talk about this later on today. The goal is to enable discussion across contributors. This is how we share our knowledge. As I mentioned, we have very strong conventions. There are coding conventions, there are naming conventions, there are documentation conventions. As I mentioned, we're going to test absolutely everything. We're going to run the tests, and each time there's a bug, we're going to add a new test. And Jerome will talk about this later. We're focused on users. Our goal is to enable users. Usability is key, and we're not thinking that users are stupid. They're busy. Just like I'm busy. When I pick up a tool, I want to be able to solve my problem quickly and not go through 3 hours of documentation. We are going to have to design the tool to solve the user's problem. And so for this, we need to know what users are targeted. Different users come in with a different background, and so they have different concepts in mind, and our tool needs to be adapted to those concepts. And this is actually challenging because we might be addressing a variety of different users. For instance, Nilearn is addressing people with more math or computer science background, but maybe also people with more psychology background. It is feasible to address those different backgrounds. We just need to make sure that we use the right terms for everybody and we explain the right concepts everywhere. It all goes back to the project vision. Our goal is to reduce the user's cognitive load. It's back to design, and design is an extremely hard problem. Jonathan Ive, for instance, was an industrial designer originally, and he ended up being number 4 at Apple. To facilitate, we'll be avoiding jargon, and our goal really is going to be to facilitate the first half hour with the project. Because if we do this, we're lowering the cognitive load. We also should know when to stop. There are problems that we can't solve, so we should avoid magic. By magic, I mean doing decisions for the user. We can suggest decisions, but if we magically choose to do A or B depending on the user inputs, then maybe it feels cool in the beginning, but then you don't really know what the library is doing. And I often say, we don't solve hard problems. If the problem is genuinely really hard, then we won't be able to come up with a really good solution to it. That's okay. We'll just solve other problems. So I want to wrap up. I presented a few thoughts about how to build a project to be sustainable. I won't list all of them, but when I think about our project, I really think about the long term, because this is how the project will win. The reason is that a project's reputation takes years to build. The user base takes years to increase, because the way user base increases is that users learn how to use a tool, and then they explain it to other users. You know, their lab mates or their students, and slowly but surely, the user base grows. And once the user base is big enough, then this project has become a valuable thing by itself in the community. This is what we want to achieve. For this, I really want to stress that quality is crucial, that complexity is absolutely a killer. I think about a project's life as having a period where it puts in weight, and that's a good thing. And after a while, putting up too much weight will kill the project. So basically, there's only a limited amount of things you can add to a project before it starts crumbling. Nilearn is not there. It has a lot of growth to go, but we need to keep this in mind today. And for this, it's crucial to keep in mind the 80-20 rule. We want to include the features and the code that will solve many problems at once, and not the niche features. And as often with engineering, everything is a matter of trade-off. There are no easy calls. We always need to consider different aspects of the trade-off when we're making our decisions. Thank you. And if there are any questions, I'm happy to take them now. I think I see questions. Let me check. Oh, no, there are questions from the previous talk. Oh, there's a question. There are a few questions. Would we consider type hints as something positive for Nilearn and reasons extra cost? I think this question is maybe to be asked at a wider audience, because it's about knowing our developer base. Is our developer base happy with type hints? Does our developer base use tools that benefit from type hints? If so, it's a good thing. If the developer base doesn't use tools that benefits from type-ins, if the developer base looks at types and think, oh my God, I don't understand this, then we shouldn't add them. So, maybe we should open an issue and ask for comment on it. For people interested in making career out in open source development, and Nilearn specifically, could you briefly speak about the structure of Nilearn as an enterprise and company? You mentioned grants. Does Nilearn function based on grants? I like to think about software, including scientific software, in terms of company, because it's all a question of balances, of basically balancing budget and resources and costs. It's crucial to have this in mind. So the way Nilearn functions is mostly we've been trying to get grants for it, and it's been mostly Bertrand and I, and ideally I would like other PIs to get involved. The reason if it's Bertrand and I, it becomes a monoculture. It becomes Bertrand's project and my project. But to be fair, only a small fraction of the features are contributed by the people who paid on the project. And we have many crucial contributions, for instance, like Julia's contribution earlier, that are done by people who are external and who dedicate a small fraction of their time. And to me, these people are crucial because they're what brings diversity of points of view to the project, and they are what will ensure a future to Nilearn. Nilearn, as a community-driven project, is a small fraction that is maintained via money, and a larger fraction that is maintained via contribution. The small fraction is crucial because it's core maintenance. What kind of grants? Honestly, it's a lot of the money we've been getting has been internal to INRIA. So we should really thank INRIA for this. We will probably try to get money from agencies such as the Chang Zuckerberg Foundation. So if the Chang Zuckerberg Foundation does another call, I think we'll be quite interested in answering this call. And ideally, I would like us not to answer this call alone, not Bertrand and myself, but ideally a joint call with, for instance, NIBabel, to have a wider ecosystem. I will share the slide online. How different is it to write a grant for scientific software compared to, say, traditional research topics? Well, something that's very important in terms of scientific software and grants and publication is that when writing a grant for scientific software, one shouldn't forget the science. Scientific software is motivated by science, and it's important to show that the software or the new features that one is thinking about will lead to better science. And that's absolutely crucial, and goes back to avoiding feature creep, the 80-20 rule, and everything. It's a question of focus. So and that's true for grants, it's also true for publications. As an editor, as a reviewer, I get papers about scientific software, and reading the paper, it's, okay, so somebody has written a software, but it's really not clear what scientific progress is going to come from this software. So scientific software is above all about science, but also very much about software. We need to get the software right. We need to do the technicality, the engineering right. We need to get the science right. Okay. I think we might be done with the questions, if there are no further questions. Oh, not a question. Okay. Rick, Simple Made Easy. I haven't seen it. I should look. So there's a comment about a good slide deck about Simple Made Easy, which I haven't seen, and so I should look at it. It's actually really hard to understand, to be sophisticated enough to do things in a simple way. What's the schedule like? Yes, we are getting close to the time for a break. How do we ensure decentralized governance? That's a good question, and I don't think we've been very good at this because Nilearn was built in a given lab. So we rely a lot on GitHub. We haven't had a formal governance with Nilearn so far. We should at some point add one. Once again, it's a question of trade-off. Formal governance basically adds bureaucracy because it means that there's a process. I'm in other projects. The break. When is the break? Well, I'll look at when is the break later. So formal governance adds bureaucracy. You need votes. You need to keep a track record. You need a committee. Now the good thing about this is it makes everything transparent. The drawback of Nilearn as it is that things are probably not as transparent as they should be. So you get the cost is bureaucracy. Basically doing things is less agile. The benefit is transparency. And my point of view is that as a project matures and it gets bigger, you need to slowly go from one to the other. And I think Nilearn is currently in the process where it should be adding more formal governance. In a sense, I think where we've delayed this is that we find that the team is currently too heavily French, I should say. And so we would really like, the day we establish a committee, we would really like this committee to have a diverse set of people on board. And so basically, I guess that's a hint, contribute now and be part of the Nilearn community. With regard, I'm rereading Sebastian's question, limiting the complexity and communication overhead. A lot of this is social, and it's really hard to define exactly how to do things. But it's basically, it's an attitude and norms to simple decision making, and it's the challenge is that decisions are not always simple. Julia mentioned that we need to do, for the surface base, we need to make technical choices, and those technical choices are extremely hard. So there are technical choices that are hard, and then there are project vision that are really hard. Should a feature come in or not? This is extremely hard, but should a feature come in or not at some point is something that will need to be decided via votes. Yeah, no, I'm sorry. I'm thinking as I speak, and I'm basically posing myself. Also, yes, Elizabeth is right. This platform works much better on Chrome. If there are no longer questions, I think, if I'm not wrong, that we're right in time for a break. So there's a long break, which will allow some people to have lunch and others to have tea. And after, we'll have Elizabeth, who will talk about using GitHub to basically engineer as much collaboration as possible across people, because coding is a social activity above all, even beyond a technical activity. Then Chris will talk about testing, Jérôme will talk about our continuous integration platform. And Alejandro will talk about the Python ecosystem for neuroimaging. Yes. OK, if we're done with questions,